Hello everyone, welcome to this session. In this session, I am going to explain about the center of gravity CG and moment of inertia I of some important shapes. Okay, before going to these CG and moment of inertia for different shapes, we are going to take that is what are these definitions of these two. Center of gravity CG. Center of gravity of an object is the point at which weight is evenly distributed in all directions. Okay, from that point, the weight is evenly distributed in all directions, or it is a point about which weight of the body or a system is supposed to act. The weight of the body or a system is supposed to act. That point is called as a center of gravity. Then moment of inertia, I. The moment of inertia defined as the quantity expressed by the body resisting angular acceleration. Okay, this is the quantity which is expressed which resists the angular acceleration of the body, which is the sum of the product of mass of every particle with its square of distance from the axis of rotation. Okay, that is the product of the mass of the every particle with its square of distance from the axis of rotation about which it is supposed to rotate. The moment of inertia is scalar quantity. It is only having the magnitude, not having the any direction. That is a scalar quantity. Moving to some important geometrical shapes. Those are here we can see the serial numbers 1, 2, 3, 4. This is the name of the figure or a name of the different shapes. The triangle, which is shown in 3.3 sketch, a rectangle, which is shown in 3.4, circle 3.5, trapezium 3.6. Then first we will take that is a center of gravity. There is a point about which the weight is evenly distributed, or point about which the weight is supposed to act. That is the center of gravity from the base. Okay, from this base, that center of gravity point we are going to take. That is x will call the CG, and that is x h by 3 for the triangle. Okay, this G point whatever is shown, that is the center of gravity of the triangle, and that distance from the base whatever is taken h by 3 x. Okay, for the rectangular, d is taken as the depth, b is the breadth, and for this about the base if you take, okay, g, this is the center of gravity, and this is half of the depth, d by 2 we can have. And for the circle also, x is equal to d by 2, where d is the diameter of the circle, and x for the trapezium shape, that is a 2a plus b by a plus b into h by 3. A is the smaller distance length of the trapezium, that is a larger length of the trapezium. H is the height. Okay, by taking these three dimensions, we can take the uh, CG of the trapezium. The G point is shown for the trapezium shape also. That is x is equal to 2a plus b by a plus b into h by 3. The area of the these different shapes we can take the BH by 2 of BH for the triangle, BD as a breadth into depth for the rectangular, pi d square by 4 for a circle, and trapezium A plus B by 2 into H. Now coming to the moment of inertia, the I about an axis passing through the CG and parallel to the base. Okay, this about this point, the axis passing through the CG and parallel to this base. Means here about the center of gravity only. Okay, about the center of gravity line, the whatever the moment of inertia is there, that can be given for these different shapes. First for the triangle, it is BH cube by 36. B is the base, H is the height cube by 36. And for the rectangular, BD cube by 12. We breadth into depth cube by 12. And for the circle, it is a pi d square by 64. Pi d square by 64 it is. And for the trapezium, a square plus 4ab plus b square by 3b into a plus b, okay, into h square. This is the equation for the moment of inertia about the center of axis passing through the center of gravity, axis passing through the center of gravity. This equation we should know. And moment of inertia about the base only, for which we can take for all the bases. And this is even for the equations for the triangle and rectangle shapes only. The BH cube by 12 for the triangle, and BD cube by 3 for the rectangular. Okay, these shapes we can have. And these, whatever the center of gravity and moment of inertia, the values are there. These are very important for uh, designing that whatever the floating and the submerged bodies. These are very important for the floating and submerged bodies, and we are going to discuss in detail about the finding of the center of gravity and distance of the center of gravity for the different shapes. Okay, in the particular the submerged and the floating bodies. Thanks for watching. If you like, share, subscribe, and comment.